Greetings for the day. Welcome to another session of soft computing. My name is Mohammed Rahmatali. In today's session, we're going to learn about the limitation of neural networks and what is supervised learning. Now, before going into this topic, let me rewind what are the things that we have studied in the previous session. We studied about the types of neural networks, the application of neural networks, and what are the different things involved with reference to feed forward network and other things. Now we're going to learn about what are the limitations of neural networks. The first one is backpropagational neural networks and many other type of networks are in a sense the ultimate black boxes. Apart from defining the general architecture of a network and perhaps initializing seeding it with a random number, the user has no other role than to feed it input and watch it train and await for the output. In fact, it has been said that with backpropagation, you almost don't know what you are doing. Some softwares freely available or some softwares are freely available and that are software packages do not allow user to sample network progress at regular time intervals, but the learning itself progress on its own. The final product of this activity is a trained network that provides no equation or coefficient defining a relationship, as in regression, beyond its own internal mathematics. This network this network is the final equation of the relationship. It means what actually this says. This is about the backpropagation type of a thing. It need to train itself. There are no other computational things which can help this particular thing in generating the outputs. There is no external things by which we can say that at this point of time you can generate this amount of output. No, after learning a lot of recursion, then only the system will learn how to process an input and how to get a required output with reference to the input given. Now the second point says backpropagational network also tends to slower to train than other type of network and sometimes require thousands of epochs. If run on truly parallel computer system, this issue is not really a problem. But if the BPNN is being simulated on a standard serial machine, that is like the single SPARC or Mac or PC, training can take some time. This is because the machine CPU must compute the function of each node and connection separately, which can be problematic in very large networks with a large amount of data. However, the speed of most current machines is such that this is typically not much an issue. So these are the limitations with reference to the neural networks. Now, coming towards the supervised learning networks. Now, in the first chapter, if at all if you remember, we studied about the supervised and unsupervised learning. What do you mean by the supervised learning? Supervised learning, as the name suggests, like it is being monitored under a supervision. Under a supervision, and it is like a model in which I want a required output with the input being given. For instance, if at all I want the output as 4. So what are the possible things by which I can get the output as 4? This is the thing which is being monitored with reference to supervised learning. For in the sense, see, I want to get an output as 4 in the sense, what are the different methods? There are n number of infinity numbers by which I can get the output as 4. How? Then like 5 minus 1 is 4, 3 plus 1 is 4, 1 plus 3 is 4, 0 plus 4 is 4, 10 minus 6 is 4, and there are n number of things by which I can get the output as 4. 14 minus 10 is 4. In these different ways I can get the output as 4. In the sense, in a supervised environment I will be training my personal algorithm or my personal network so that it can give a desired output of my choice. You should give a desired output of my choice so that the person who is using that particular system can understand what actually is happening in that particular thing. So for training this particular model, it needs time, it needs a lot of efforts, it needs a lot of what you call as failure. After a lot of failure, then only you will come to know what are the different possible things that is been there for getting that particular output. Now what it says, as the name suggests, supervised learning takes place under the supervision of a teacher. This learning process is dependent. During the training of artificial neural network under supervised learning, the input vector is presented to the network, which will produce an output vector. Now, this output vector is compared with desired or target output vector. An error signal is generated if there is a difference between the actual output and the desired output vector. On the basis of this error signal, the weights would be adjusted until the actual output is matched with the desired output. Like I have given you the example, if at all I want an output of 4 but it is giving 5, 6, 3, 2 or any other things, now the weights will be adjusted by which inputs I will get the desired output. What are the different inputs by I will be getting this particular desired output. If at all there is an error, the weights will be changed. If at all the output what I want is correct, so I'll be matching those inputs in my learning networks. Now what it further says, it means like the next one is the perceptron or perception model. Okay, now what it says, developed by Frank by using Makela and Pitt's model, Perceptron is the basic operational unit of artificial neural network. It employs supervised learning rules and is able to classify the data into two classes. What are the two classes? We'll see in the upcoming slides. Now, operational characteristics of this perceptron is it consists of a single neuron with an arbitrary number of inputs along with adjustable weights, but the output of the neuron is either 1 or 0 depending on the threshold values or depending upon the threshold. It also consists of a bias whose weight is always 1 and consists of a weight which is always 1. Following figure gives a semantic or systematic representation of the perceptron model, in which these are the weights that are been given, this is the computational things, and this is the activate function, and this is the output. If at all I want a desired output, here the weights will be changed and here the learning will be taking place. Here are the input, the different input that I will be getting, here is the computational values, and here is the output that I will be getting, and here will be the learning what you call as mechanism. Now how it is been done, like it is been done in this way. Perceptron has the following three basic elements. The first one is the link, the second one is the adder, and the third one is the function. Now what is a link? It would have a set of connection links which carries a weight including bias always having the weight 1. Now what is adder? It adds the input after they are multiplied with their respective weights. Now what is activation function? It limits the output of neuron. The most basic activation function is a Heaviside step function that has two possible outputs. The function returns 1 if the output is positive and 0 if any negative input. Now what it further says, now this is the training model or training algorithm that is being used in perceptron model. How that model is been trained? In perceptron network can be trained for a single output unit as well as multiple output unit. We will see the same. The first we will see for single output unit, then we will see for the multiple output unit what actually it is. Now the training for single output or the training algorithm for single output unit is, in first step we will be initialize the following to start the training. The first one is the weight, the second one is the bias, and the third one is the learning rate. Now what it says, for easy calculation and simplicity, weights and for easy calculation and simplicity, weights and bias must be set equal to 0 and the learning rate must be set equal to 1. Why? Because if the learning rate is set to 0, then every of the input that we are giving, the outcome will be always 0. Now what is the next step? In step 2, continue the step from 3rd to 8th when the stopping condition is not true. In the sense, when we are getting a desired output, then we can stop this training. When we are getting the desired output, we can stop the training. Now what is the step 3? Continue with step 4 to step 6 for every training vector. If at all, if you want to train the model, like if at all if I want to get a desired output, so what is the activation things? The step 4 says activate each input unit as follows. Here we'll see like what are the inputs and what are the outputs that we'll be getting. Now what is step 5? Now obtain the net input with the following relation. This is a relation that is been given. Here B is the bias and N is the total number of input neurons. Now what is the step 6? Apply the following activation function to obtain a final output. This is a function for obtaining the final output 0, 1 and minus 1. Minus 1, 0 and 1. If this is a condition, if y of n is greater than 0, if minus 0 and is greater than y of n and y of n is greater than 0, greater than or equal to 0. If this is the condition that is been given, this is the condition that is been given. Now what is step 7? Adjust the weights and bias as follows. Adjust the weights and bias as follows. Now what is the adjust weights? If y is not equal to t. If y is not equal to t, in the sense the input or the output or the actual output and the output that we are getting, if it is not equal, then this condition is to be applied. This condition is to be applied. If the desired output and actual output are same, then this condition need to be applied. This is the condition that need to be applied. Now what it is saying here, y is the actual output and t is the desired or target output of that particular system. Now these are the output values that we will be getting. And what is the last step? Test for the stopping condition, which would happen if there is no change in the weight. If there is no change in the weight, then stopping function or stopping condition will be applied. This is with reference to the single output unit. This is with reference to the single output unit. Now with reference to the multiple output unit, the same thing will be applied on multiple output unit. The same thing which has been applied to single output unit will be applied to multiple output unit, but with small minor changes. If at all, if you observe this diagram, here there is one adder thing and multiple inputs, but if at all, if you observe here, there are multiple levels of performing a task. Now why these multiple layers are there? This extra layer that is been here is to take improvised decision, is to take some improvised decision with reference to the single model. Now what it says over here, the following diagram is architecture of perceptron for multiple output classes. For multiple output classes. Now how the training will be done? Now the first one is initialize the following to start the training. The same way that I have told you in the single output model, weights, bias and learning. For easy calculation and simplicity, weights and bias must be set equal to 0 and the learning rate must be set equal to 1. Now what is step 2? Continue step 3 to step 8 when stopping condition is not true. The same thing is being applied over here, but the method or the condition which is been applied over here is different from single to multiple. The same steps. Now what is the fourth step? Activate each input unit as follows. X of I is equal to S of I equal to 1 ton or Y t of 1. Okay. Now fifth step is obtaining the net input with the following relations. Y of in is equal to b summation of in xi wij yn is equal to b plus summation of in xi wij. Now here the b is bias and n is the number of input neurons. Here b is bias and n is the number of neurons which is been here. Now what is step 6? Apply the following activation function to obtain the final output for each output unit j, or j is equal to 1 to m. Now if at all, if you observe in the previous thing, it was only single value, but here is a multiple value. Why? Because it is multi-level type of what you call as multiple output unit, but previously it was single output unit, so we are getting only single output, but with reference to multiple, here we are getting multiple level of outputs. Now what it says, adjust the weight and bias for x equal to 1 to n and j equal to 1 to m as follows. So because in previous thing it was single, here it is multiple, so we will be getting multiple values. If at all y of j is not equal to t of j, then if at all the actual input is not equal to the desired the actual output is not equal to the desired output, then this condition will be applied. This is a condition which will be applied. If at all, if y of j is equal to t of j, then this condition will be applied. Y of w of ij of new is equal to w of wij of old into wij of new is equal to wij of old. Okay, now here y is the actual output and t is the desired or target output. Now what is the step 8, the last step? Test for stopping condition, which will happen when there is no change in the input, or when there is no change in the weights of the function. This is with reference to multi output units. Previously was for single output unit, this is for multiple output unit. Now the next one is the adaptive linear neuron or Adaline. So what it is, Adaline, which stands for adaptive linear neuron, is a network having a single layer unit. It was developed by Woodrow and Hoff in 1960. Some of the important points about Adaline are as follows. What it is, it uses bipolar activation function, in the sense two-way activation function. It uses delta rule for training to minimize the mean squared error MSE between the actual output and desired target output. The weights and bias are adjustable. In the sense, see, in all of the supervised learning, the weights can be adjusted to get our desired output with the actual output. What is the desired output that we want and what is the actual output that need to get is can be adjusted with reference to the weights that is been given as an input or given to the system. For that particular purpose, we will be training those all things. See, what are the things that is been written over here is very much simple. If once you understand the concept is the input that we are giving and the output that we are getting, or the input that we are giving and the output that we are getting, if this should match with one another. As I have told you, it is not only one method of getting 4. There are n number of methods by which I can get the output as 4. For an example, 104 minus 100 is 4. It is 4. Or it is like 108 minus 104. The output is 4. In a sense, as the weights or the inputs are changing, I am getting a desired output. So I will be adjusting the weights or adjusting the input so that I can get a desired output with reference to the model. This is how we train the model. With different n number of type of inputs. The way we learn with our own choices, like we apply for different methods by which I can learn the things. Like some people can directly understand what I am saying. Some people need some of the examples to understand things. Some people need more attention to make this particular things understandable. So for different things, we try to learn from different methods. As the weights are changing, as my methodology of teaching is changing, you are able to understand in a better way in different things. And the way you have understood the VGR color, the way I told you about the different things, with reference to an example, you are able to understand that particular scenario with reference to that example. In the same way, we are able to make different inputs to get a desired output. In the same thing applies over here. What is the architecture of adaptive linear neuron Adaline? Or the basic thing is, the basic structure of Adaline is similar to Perceptron, having an extra feedback loop with the help of which the actual output is compared with the desired output. After comparison, on the basis of training algorithm, the weights and bias will be updated. Now what actually happens over here? See, when we are giving the inputs, this output is being compared. This comparison with the target output. This is being compared. after getting the output or after getting into the function, we'll be comparing with the weights. If at all it is not okay, then we'll be adjusting the inputs. So that we can get the desired output. Sorry, this is how the things will work. The same thing applies over here, the training model, the same old thing, but the only thing that changes here is the method that we apply, the final method that we apply. The same thing applies over here, but the only thing is like we will be cross verifying the input. Here we will be cross verifying the input with reference to the output that we are getting. In the sense, we will be having a comparison of target outputs. Now what it over says, with reference to the training model, step 1, initialize the following to start the training. What is the training? Weight, bias and learning rate. Now for easy calculation and simplicity, weights and bias must be set equal to 0 and learning rate must be set equal to 1. Now the second step, continue step 3 to 8 when the stopping condition is not true. Now what is the third step? Continue the step 4 to 6 for every bipolar training pair S and T. Now what is the fourth step? Activate each input unit as follows. Xi is equal to Si of I equal to 1 TON. Now what is the step 5? Obtain the net input with the following relation. Y of In is equal to B plus summation of Xi Wi. Okay, here B is bias and N is the total number of inputs neuron. And now what is the step 6? Apply the following activation function to obtain the final output. 1 and minus 1. 1 and minus 1. Now what is the step 7? Adjust the weight and bias as follows. If y is not equal to 10, then this is the condition that will be applied, and if y is equal to 10, then this is the condition that will be applied. Here y is the actual output and t is the desired target output. Okay, now what is the step 8? The test for the stopping condition, which will happen when there is no change in the weights or the highest weight change occurred during training is smaller than the specified tolerance. This is the step 8. Now this is with reference to the training model of adaptive linear neuron. This is with reference to the adaptive linear model. Now moving towards the next model, which is multiple adaptive linear model. This was with reference to the linear model, adaptive linear model. This is with reference to multiple adaptive linear neuron. Now what it is here, Adaline, which stands for multiple adaptive linear neuron, is a network which consists of many Adalines in parallel. It will have a single output unit. Some important points about Adaline are as follows. What is the thing? It is just like a multi-layer perceptron, which Adaline will act as a hidden unit between the input and the Adaline layer. The next point is the weights and the bias between the input and Adaline layer we can see in the Adaline architecture are adjustable. The Adaline and Adaline layers have fixed weights and bias of 1. The next point is training can be done with the help of delta rule. Now what is there, we'll see in the coming slides. This is the architecture of multiple adaptive linear neuron. What it says, the architecture of Adaline consists of n neurons of the input layer, m neurons of Adaline layer and 1 neuron of Adaline layer. The Adaline layer can be considered as the hidden layer as it is between the input layer and output layer, that is Adaline layer. This is with reference to the architecture of multiple adaptive linear neuron. Now what is with reference to the training model? It also follows the same thing, like training the models follow the same thing for everything in supervised learning. This is with reference to the supervised learning. By now we know that only weights and bias between input and Adaline layers are to be adjusted, and the weights and bias between the Adaline and Adaline layers are fixed. Now what is the first step? Initialize the following to start the training: weights, bias and learning rates. For easy calculation and simplicity, weights and bias must be set equal to 0 and the learning rate must be set equal to 1. The second step is continue step 3 to 8 when the stopping condition is not true. Now what is the third step? Continue step 4 to 6 for every bipolar training pair. What is it? S to T. Now step 4, activate the input unit as follows. X of I is equal to Si of I equal to 1 ton of Xi equal to Si of I equal to 1 ton. Now what is step 5? Obtain the net input at each hidden layer, that is the Adaline layer without the following relation, or sorry, with the following relation. What it is? Q of I and j is equal to bj plus summation of xi, wij and j is equal to 1 to m. Here b is the bias and n is the total number of input neurons. This is with reference to the multiple adaptive linear neurons. This is with reference to the training model. Now what is the next step that will be there? Apply the following activation function to obtain the final output of Adaline layer. And this is the function f of x is equal to 1 if x is greater than or equal to 0, minus 1 if x is less than 0. Output at hidden Adaline unit is qj is equal to f of qi and j of, or qij, sorry, if output at hidden Adaline unit is qj is equal to f of qi and j of qj equal to f of qi and j. Final output of the network will be y equal to f of yin, y equal to f of yin, that is yinj is equal to b0 or bo plus summation of mj equal to 1 qjvj. So this is the final output that we will be getting. Now what is the seventh step? Calculate the error and adjust the weights as follows. If y is not equal to t, then t equal to 1, and if y is not equal to t, t is equal to minus 1. If y is equal to t, then there will be no changes in the weight. Now if at all, if y is not equal to t and t is equal to 1, then in this case the weight would be updated to, or updated on qj, where the net input is close to 0 because t is equal to 1. If at all y is not equal to t and t is equal to minus 1, in this case the weight would be updated to on, or the weight would be updated to qk, where the net input is positive because t is minus 1. Now what is the step 8? The same thing. For test for the stopping condition, which will happen when there is no changes in the weights, or the highest weight can change occurred during training is smaller than specified tolerance. This is with reference to supervised learning. I hope you understood something from today's session. This was a bit heavy for today's session. If at all, if you have any doubt with reference to today's session, you can ping me on my email address rahmat_ali2u@yahoo.com, or you can come down to the college for a personal doubt clarification. That's all for now. See you in the next session. Have a great day. Until then, take care. Bye bye.